All right, so a really important part of probability is counting the number of outcomes, right? When we go to find any kind of probability, you always have to use favorable outcomes over total number of outcomes. And so to find the number of favorable outcomes or total number of outcomes, you can write out the sample space, or you, hopefully we can find some shortcut ways to find, how many there are, because that can save us a lot of time. Sometimes there's, a huge number of sample space, and it's really difficult to write out. So that's what we're going to focus on today, is how do you count the number of outcomes in different situations. So this one says 2 coins are flipped and a spinner is spun. Tree diagram shows the possible outcomes. How many outcomes are possible, right? So I could get a heads, heads 1, heads, heads 2, heads, heads 3. There's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a total of 12 possible outcomes. What I wanted to remind you of is, I think I pointed this out in some earlier videos, but if I take the first event, right, you flip the coin, there are 2 possible outcomes. Second event, you flip the coin, there are 2 possible outcomes. Third event, you spin the spinner, there are 3. Okay, if I times those together, right, 2 times 2 times 3, that gives me a total of 12 possible outcomes. And you can kind of visualize that by looking at the tree, why it works that way, right? I have 2 here. For each of those 2, I have 2. And then for each of those, I have 3. This is something called the fundamental counting principle. So pause this for just a second and write it down. But it states that if there are P ways to do one thing and Q ways to do another thing, then there are P times Q ways of doing both things. Now that's only talking about 2 things, but it could be three events, 4 events, 5 events. You could have a lot of events there, but you just times the number of ways each one has together, and that gives you the total number of outcomes. So this is an example, and it says how many events are shown, right? So I have the first event, there's 2 outcomes. The third event, there are 3 outcomes. The fourth event, there are 2 outcomes. The fifth event, there are 2 for each of those. So if I times all those together, 2 times 3 times 2 times 2, that's 6 times 2 is 12 times 2. That means there's 24 possible outcomes. And I think if you count across here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, right? We get to 24. So you can make a tree diagram and get this and find the possible outcomes, but you can also use this fundamental counting principle, which makes it much, much easier. What we're going to focus on today is ways to find outcomes. And there's a couple different types of counting, ways of counting. And those 2 different things are called permutations and combinations. So we'll talk about what those are, and we'll give you a formula you can use to find those. A permutation is an arrangement of objects in which the order is important. So if the order matters, if the order is important, then we consider it to be a permutation. So this says how many different ways can you arrange A, B, and C? So what this is talking about, right, is I could have A, B, C, there's one. I'm going to take out the commas just to make it easier. So you could have A, B, C. You could have A, C, B, right? And because it's a different arrangement, we're arranging it, like the order matters. Okay, the order is important. If I switch the order, even though they're the same 3 letters, it counts as a different arrangement, a different order. We could do, we'll have to put the B first. So B, A, C, or we could do B, C, A. Or I could also put the C first. We could do C, A, B, or we could do C, B, A. I think I have them all there. So we got, how many different orders could you have? 1, 2, 3, 4, 5, 6. So there are 6 permutations there. In other words, there's 6 different ways I could arrange the order of those letters. Here's one. Consider the number of permutations of the letter in the word July, and how many ways can you arrange all the letters, part A. B, how many ways can you arrange 2 of the letters? So this gets a little bit tricky. Like if I try writing the sample space down, that takes a long time. So I'm going to approach this a different way. I'm going to approach it using the fundamental counting principle. So picture if I have, the word July, and I have each of those letters, and I put them in a bag, and I want to draw them out, right? If I draw out the first one, how many possible letters could I get? Well, there's a J, U, L, Y, there's 4 letters. So I draw out the first one, that means I could get any one of those 4. When I go to draw out the second one, I'm not putting the letter back. When I go out to draw the second one, I'd only have 3 to choose from. When I go to to pull out the third one, I would only have 2 to choose from. When I go to pull out the last one, I'd have 1 to choose from. So if I use a fundamental counting principle, I have 4 choices on the first event, 3 on the second, 2 on the third, and 1 on the last one. So if I times all those together, I end up with 24. So there's a total of 24 different ways you could arrange the letters in July. That's much better, right? Much easier than trying to actually write out the sample space. That would not be fun. Hey, part B says just 2 of the letters. So in this case, think of it the same way. Like you put all those letters in a bag and you're going to pull them out. But this time you're only going to pull out 2. So I pull out the first one, there would be 4 possibilities. But for the second one, there would only be 3. So for that one, how many different possible ways could you arrange 2 of the letters? The answer is 12. Okay, there's 12 possible ways you could rearrange. I want you guys to try a couple of these. So pause this and see if you can get the answer for these 2, and then I'll work through it. So the first one, it says, how many ways can you arrange the letters in the word house? So how many letters are there? There's 1, 2, 3, 4, 5. So again, picture those all thrown into a bag, and you go to pull out the first one, you would have 5 choices. There's 5 possible outcomes. I could get an H, O, U, S, or an E. For my next one, though, there would only be 4 because I took 1 out, and there would only be 3, and then there would only be 2, and then there would only be 1. So we multiply all those together. 5 times 4 is 20, times 3 is 60, times 2 is 120. So there's 120 different ways, different combinations you could get different ways you could arrange those letters. Number 2 says, in how many ways can you arrange 3 letters in the word March? Okay, so we have a total of 1, 2, 3, 4, 5 letters. When I go to choose my first one, then I have 5. Second one, I have 4. Third one, I have 3. So I only have those, times those together. 5 times 4 is 20, times 3 is 60. So you'd have a total of 60 different ways you could just draw out 3 of those letters. You could arrange 3 of them. So can you imagine trying to write that sample space? You know, M-A-R, M-A-C, M-A-H, and then you could there would be a total of 60 different ones. We don't want to do this by writing out the sample space. So we want to think through these logically. Okay, sometimes, these get complicated, and there is not, and we can't just think it through the way I was just doing it. So there is another option, and that is we can use these formulas. So you don't have to memorize these, but I do want them in your notes so that you have them to refer to as you take your test. So it says up here, here's my permutation formula. It says the number of permutations of n objects, so n is how many objects you have, is given by, so it says n, the n is how many you have to choose from, permutation, and if you're choosing all the objects. So for example, if I have 5 letters and I'm drawing out all 5, then you use this formula. It's called n factorial. So n factorial, when you see this, really, so let's use this example right here. I have 4 permutation 4. So it's just equal to 4 factorial. This is what 4 factorial means. It means 4 times 3 times 2 times 1. If I said, what is 7 factorial? It is 7 times 6 times 5 times 4 times 3 times 2 times 1. So that factorial, the exclamation mark, just means you're timesing those in descending order like that, all the way down to 1. So that's pretty easy. And that's what happened back here. If I go back to here, to this first problem, if we're drawing out all the letters, there's 1, 2, 3, 4, 5, we would say there are 5 letters to choose from, and we're choosing 5. The formula is simple. It's just 5 factorial. And that's really what we did, right? That's when we did the fundamental counting principle, we did that same thing and ended up with that same answer. The second formula is if you have n objects to choose from and you're choosing r. Now r has to be less than n, right? I can't have 10 objects to choose from and choose 12. It doesn't work. So r has to be less than n. but you use this formula right here. It's n factorial over n minus r factorial. So an example of that would be like this last one right here, where we had 5 letters and we were only choosing 3. So you'd write it like this: permutation. I have 5 to choose from. I'm choosing 3. So our formula is n factorial. 5 is n. That's how many I have to choose from. Over n minus r factorial. 5 minus 3. Okay, to work that out, right, the top ends up being 5 times 4 times 3 times 2 times 1. The bottom ends up being 2 times 1. All that happens is those cancel out. So if you wanted to, you could think of it this way. You just go 5 times 4 times 3 times, and I'm going to stop at 2 because I have a 2 down there. Cancel those out. And that ends up being the same thing we had right there. Really, with permutations, I kind of like doing the fundamental counting principle rather than the formula. I just think it's easier. The one advantage to the formula is if you do have a scientific calculator or a graphing calculator, you can actually do those in your calculator. So that's the one advantage of the formula itself. Okay, this one says 10 horses are running in a race. In how many different ways can the horse finish first, second, and third? So you got to first decide, is this a permutation? With permutation, the order matters. So for example, let's say you have 3 horses. Does it matter what order they come in? And the answer is yes. If I have I don't know, one horse named Fred and another horse named Joe, if it's Joe, Fred, first and second, that's different than Fred, Joe, first and second. So it does matter what order they come in. If you switch the order of the first, second, and third finish, it counts as a different finish. So this is a permutation. So since it's a permutation, we're going to use our formula. It's a permutation. We have 10 horses to choose from, and we're only choosing 3. There's 3 finishes, first, second, and third. So our formula would be 10 factorial over 10 minus 3, which is 7 factorial. When I go to work that out, it ends up being 10 times 9 times 8 times 7 factorial, all over 7 factorial. I don't have to go any further because those 2 will cancel out. Times those together, that's like 720. There's your answer. I want to point out, I think it's easier just to do this. For the first place finisher, you have 10 possibilities. For the second place finisher, you only have 9. For the third place, you only have 8. That's the same thing, right? 10 times 9 times 8. So out of permutations, the formula isn't as important. You can always do the fundamental counting principle. It's combinations, which we're going to do next. It's a little bit trickier. Here's another one for a town parade. You ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. What is the probability that your float is first and the float with the school chorus is second? Okay, I want to notice something here. This is a different problem. This is asking us to find the probability. The last questions were only asking us to count the number of outcomes. So this is a little bit different. So we need to find the probability. So remember, it's the number of favorable outcomes over the total number of possible outcomes. Okay, so find the probability, right? It's favorable outcomes over possible outcomes. Just like you guys have been doing that forever. So to find the number of favorable outcomes, there's only one. You want your boat first and the school boat second. So really there's one favorable outcome over the total number of possible outcomes. Well, think of all the different ways the first 2 positions could be arranged. And the order matters, right? If your float's first and the chorus is second, that's different from the chorus being first and you being second. So we're going to do a permutation. The order matters. We have 12 boats to choose from, and we want to find out how many different ways you could arrange the first 2 boats. So we're going to do that 12 permutation 2. So that'd be 1 over, and we got to figure out what this is equal to. So let's figure that out. That's 12 factorial over 12 minus 2 factorial, which is 10 factorial. So that'd be 12 times 11 times 10 factorial. Those cancel out. 12 times 11 is 132. So you have a 1 in 132 chance. So remember, know where both these numbers came from. One is how many favorable outcomes. There's only one combination that you'd be happy with. Your boat first, float first, the school chorus second. This number came from how many possible different arrangements are there for those first 2? How many different ways, if you take those 12 boats floats, excuse me, if you rearrange those first two. Okay, I want you to try these two. Pause it, try them, and then come back and we'll go through it. So the example 2 says suppose there's 8 horses in the race. How many different ways could the horses finish first, second, and third? Hey, the only difference there is, again, order matters, but there's 8 horses to choose from, and you're choosing 3. So that would just be 8 factorial over 5 factorial. It's going to end up being 8 times 7 times 6. Suppose there are 14 floats in the parade. Find the probability that the soccer team is first and the chorus is second. So again, you want one specific combination. You want the soccer team first and the choir second. So that means there's 1 out of. This time there are, 14 floats, but you're still choosing 2. So you'd figure out what that came out to be. It's going to be 1 over 14 times 13. Whatever that comes out to be is going to give you the probability. Okay, big thing with permutations. In permutations, order matters. That's important because we're going to talk about combinations right now. A combination is a selection. Notice it doesn't say an arrangement. It's a selection of objects in which order is, this is important, is not important. So the order doesn't matter. I find it ironic, right? You have a combination for a lock. It's kind of funny that they call it a combination because in a combination it does matter what order the numbers are in. So mathematically that's a stupid name for a lock, right? It should be a permutation, not a combination. Because the order matters, right? Wait, so in a combination, order is not important. It doesn't matter. And I'll show you some examples. So this one says, count the possible combinations of 2 letters chosen from the list A, B, C, and D. So this time, it says count the number of possible combinations of 2 letters. So when you say a combination of 2 letters, it doesn't matter if it's A, B, or B, A. So let's list them all. It could be, you could have A, B, we'll write down BA. It could be BC or CB. Could be AC or CA. Let's see, which ones have I missed? It could be, we've still got some to go, right? AD or DA. It could be, let's see, we got AB, AC, AD. We got BC and CB. We could do BD and DB. Let's make sure we got all of those on the list here. I think the only ones we're missing there, we still need what? CD, I think. CD and DC. Okay, so if this was a permutation, you would say, I think there's 12 there. Let's see, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. So there'd be 12 permutations. But because it's a combination, the order doesn't matter. So what that means is getting A, B, and BA are the same thing. So I'm going to cross that off. They don't count separately on combinations. The permutation, yes, but combinations, no. BC and CB, again, they're the same thing. Order doesn't matter. AC and CA are the same thing. AD and DA. So when you get done with that, you end up with, even though there would have been 12 permutations, if order mattered, we would have had 12 different ones we could do there. When order doesn't matter, you just make it a combination, it'll be 6. So that's something to know is you're going to have less combinations than permutations, always, when you go through and find that. This is a little bit tricky then. You can't use fundamental counting principle to find the answer to these like you did with permutations. So with combinations, you need to use these formulas. Okay, so I'm going to show you the formula you're going to use. If you're doing a combination, you're going to use this formula right here. So NCR, right, N combination with R. N is still the number of objects you have to choose from. R is still the number of objects you're choosing. But this is our formula. Notice it's really similar. I still have n factorial on the top. I still have n minus r factorial on the bottom. But now on the bottom, I also have times by r factorial. Take just a second to write that down. This is really important. You have to have this formula to do a combination problem. If we go back to that last problem we just did, back here, so if we use that formula, There's a total of 1, 2, 3, 4. So it's a combination. You have 4 to choose from, and we were choosing 2 at a time. So our formula is 4 factorial over n minus r, 4 minus 2 factorial, times by r factorial, which is 2 factorial. So let's simplify that. I've got 4 factorial over 2 factorial times 2 factorial. So let's see if we can simplify that down to be 4 times 3 times 2 factorial. Hey, those 2 factorials, one of them will just cancel out. So now I have 4 times 3 over 2 times 1. So I have 12 divided by 2, which comes out to be 6. So we can get our answer. Now you can debate, was this problem easier with the formula or writing out the sample space like I did? Maybe it would be debatable on this one, but think if you have a combination, sometimes you can get 100 or 1,000 different combinations. You do not want to write out those sample spaces. So instead, we're going to use this formula. So it's really important. You have to know the difference between a permutation and combination. And the way you're going to tell always is, does order matter? If order matters, it's a permutation. And you can either use the fundamental counting principle or the formula. If order doesn't matter, then you can use this formula for combinations. So it says you order a sandwich at a restaurant, you can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So decide if order matters or not. They kind of give it away by saying combinations, but does it make sense? It doesn't matter if your combinations, what order you get them in. It doesn't matter if you get, a baked potato and some fries, or fries and a baked potato. It's the same thing. So it doesn't make a difference. It doesn't matter what order you choose them in. So this would be a combination. It'd be 8 choose 2. And now we're just plugging it in our formula. So we get 8 factorial. We go 8 minus 2, which is 6 factorial, times by r factorial, which is 2 factorial. So I'm going to simplify that. I'm going to go 8 times 7. I'm going to stop at 6. Because now I can, 2 factorial. Now I can cancel out those. So now I have 8 times 7, 2 times 1. 2 times 1. 8 times 7 is 56. 56 divided by 2 is 28. So there would be 28 different combinations of side orders that you could end up with. A yearbook editor has selected 14 photos, including one of you and your friends, to use in the collage of the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo will be the 2 placed at the top of the page? Okay, the key thing here again, number 1, is this is not just a counting problem. It's not counting. You're finding the probability. But we can use what we know about counting in order to find that probability. Okay, so when you think about this for a second, you need to find out how many different arrangements of 2 photos could you have. So it's going to be a combination. To find the total outcomes, right down here, we're going to have to do a combination, and there's 14 to choose from, and they're going to choose 2. And the order doesn't matter, right? It doesn't say it has to be you and then your friend. This could be you and your friend, or your friend and you. It doesn't matter what 2 orders those go in. So this will give us the total number of outcomes right here. So plug that in your formula. I would end up with 14 factorial over 14 minus 2 times 2 factorial. That would be 14 times 13 times 12 factorial. The 12 factorials cancel out. 2 factorial is 2 times 1, which is 2. 14 divided by 2 is 7, so 7 times 13. That's what, 91, I think. So there's a total of 91 different combinations of 2 pictures that they could put up there. Okay, favorable outcomes, you're only happy with one, and that is you want you and your friend to be at the top of the page. So we're just going to put a 1 up there. There is my probability. It's a 1 in 91. Okay, so make sure you can identify. If it just asks you to count the outcomes, that's great. It's just a number. But if it asks you to find the probability, it's going to be, set it up like a probability problem. Favorable outcomes over possible outcomes. To find the possible outcomes, you're going to be using these shortcut counting, depending on whether it's a combination or a permutation. You guys try these 2. These are our last 2 problems, and then come back and check and see if you got it. So number 6 says, what if in example 6 you had 3 side dishes out of 8 to choose from? How many combinations are possible? Okay, so we're going to go 8 combination 5, so that would be 8 factorial. 8 minus 5 is 3, 5. So I'm going to go 8 times 7 times 6. I'm going to stop at 5 factorial because now I can just cancel out those. So now I have 8 times 7 times 6 on top. On the bottom I have 3 factorial, so 3 times 2 times 1. Let's see, I can take 3 into 6 would be 2. Then I actually just cancel out that 2. So 56. You have 56 possible combinations. Number 7 says, suppose there are 20 photos in the collage. What is the probability that your and your friend's photo are the top 2? So we know it's going to be 1 out of, and down here you're going to have the combination of, now I have 20, choose 2. So you'd work that out and find it. There is actually a way to put these in. If you have either a graphing or a scientific calculator, you can it'll actually do that combination or permutation for you. Let me show that to you real quick. And I'm okay if you use a calculator if you want to. If you don't, that's fine also. So let me just pull up my screenshot here and we can get that in there. All right, so I got that up and running here. So if you have a graphing calculator like a TI, this is how you can put those formulas in this calculator. So let me show you really fast. So that problem was 20 choose 2 was the problem. 20 combination 2. Just zoom in a little bit so you can see a little bit better. So on this calculator, you just hit the math button, which is right over here. So hit the math button. And then if you scroll over, there's a probability menu right there. And then if you go down, you'll see that NPR or NCR. I do NCR, and I just I have 20 to choose from. I'm choosing 3. And I plug it in there and I get 1,140. Isn't that great? Now I don't have to go through and simplify it all by hand. Scientific calculators have them too, and they're all going to be a little bit different. Here's one example. I haven't used this one much before, so we'll see if I can make this work for you. So on this one, there's a little probability menu right there. So I think I hit the 21st. I hit the probability menu, and right there I have NPR and NCR. I hit enter on NPR, and then I put 20 combination 3, hit enter, and I get the same answer. So if you have a scientific one or a graphing one, either one, they will both do those combinations or permutations. And you notice in there's the NPR, so it will do permutations for you also. I'm perfectly fine if you use a calculator. I'm also perfectly fine if you just want to take it and write it out as a fraction like we have, like we have here, and simplify it. That's fine also. Hey, this will be the last section, so practice that. We'll be reviewing next, and then we'll take our test.